Okay, we should be good for the stream. All green. Okay, let's get started. So, good afternoon. A bit late stream today. Some business details to take care of. Uh, I'm gonna dive right into where I left off yesterday, which was the dendrites, stellar plates, thin plates, long plates, which we labeled as columns. And I think I just dumped the basic data here. Where was it? In this file here. Okay. Nope. Should be under weather system. There you go. Okay, so we had a basic if-else case here. We first check the temperature, and for each temperature block, we will have multiple if blocks, simulating the if-else cases for determining the right shape. I think it's going to be a bit more clear once I start writing the code. Not sure if Twitch is having a hard time connecting. Let me just turn things off and on again. Just going to quickly check. I think Twitch is having a hard time connecting. Try one more time and then I'll I think I'm confident it's doing it. I occasionally get the offline message, but I think we are good to go. Let's start by writing our function here. It's all going to be part of this function. So we are not passing, we are now writing it. So we need to get the temperature. So we don't actually get the temperature. We say get measurement for, because we have air temperature and we have dew point, we have other measurements. So this is what we are actually seeking. We could actually store this. This is not good. Yesterday, one of the fixes was to fix the scaling issue. Originally, this was returning 19 degrees Celsius as 190. That's now fixed. So we can do proper checks like this instead of 190. So here's the temperature. If temperature is this, we're essentially writing this. If the temperature is in this range. So we'll do load checks. If the temperature is -3 or warmer, then need to check the humidity. This is where we'll do the humidity. And I believe this is giving the percentage already. If this says 70, then I think this is what we are looking for. We'll see. Let's also store that relative humidity. Let's get RH. Okay. If relative humidity is let's just go about this as We know the minimum could be 0, which is unlikely. If it's this, then turn plate 1, which is no type plate 1. It's not less than or equal 13, which means it's kind of higher, but if it's less than this, then return plate 2. And last but not least, it's this, then you return dendrites 1. Okay. Now, can we do something like this for the temperature? Because now we'll come here and say, if temp is higher than -10, less than -3. I don't care about the equalities, but let me start to write this from reverse with like this logic, because our snow crystal type is only relevant when the temperatures are below 0. So the idea is similar to this, but we are kind of checking against its minimums, sort of like this, but it's in the bottom here. If let's pretend that this is the case. Let's say temperature is -30. Then it is definitely going to be true for this case. Now, whether it's above 90 or not, as long as it's below -22, this is what we are after. So then we have something like this. Be careful here, because this is when you get in trouble. Copy and paste. And because we have error here, comment it out. Column 2, yeah. This is 100. So this is clearly covering the 28.1. So if it's strictly 28, we still think it's plate 2. This is where we were not making that distinction, whether this is inclusive or this is inclusive. This was just a shorthand method. This is essentially saying if it's 28.1 or above, or it's strictly higher than this. This covers that case. And because if it's below 28, we return this. We don't have that problem when it's 14. It's not going to be hit because we. So now, because we have that safety method here, So we'll implement this logic sort of upwards. Now I'm going to pretend that I'm writing this. If temp is there's one problem here though. Temperature is -30. True. This is true. So the order matters here. It's like this is in the original list at the bottom. But when I write this should be the first to be. It's if the temperature is -30, just do your thing and be done with it. If it's not, then it could be between these two, so it's going to be obviously warmer than this temperature, and maybe it's going to be -15, so this is going to be okay. So this has to be coming right after this, and then we'll be done with in that. So I'm going to sort of write up and then reverse them. Writing this case, so I need 4 if blocks. Again, 22, 45. We will always have this 100 case, so I will 71. Plate 2. Stellar. Androids. This time it's going to quickly take this, put it here, because I don't have the original list. This is the list because I deleted the notepad from yesterday. So it's wrong. This one is this. This one is this. Now I'm writing this. So this is 3. Don't need 1. Column 1. Column 2. And needles. What's the range? 13, 33, and the other one is always 100. Now this is done. This is sort of done here, but it's not done at this level. So here we should actually have this. Now this has to be reversed. This has to be down here. This has to be down here. All of this is going right above. I think this is the leanest way. And there is going to be a separate mechanism that is determining whether it's snowing or not. So this function's job is to return a snow type. It's not going to determine whether it shouldn't return null, meaning that there is no snow type because it's not snowing. If it's snowing, something will ask, well, what is the type? So this is right now kind of always returning something as long as temperature is below 0. So let's save this. Okay. Look at this diagram and the code. So temperature is below -22. We will have two options. If the humidity is less than 28, then we have plate 2, or we have second column type 2. It's fine. Then if it's since let's say -15 is not higher than -22, we are here. We are in this range. Similarly, we check plate number 2. This is plate 1. This one and this one, plate 2. This is the plate 3, I think that's right. This is bigger. Yeah, that's it. 22, 45, we do that, and then 71 we have stellar, and then dendrite 2. Because this is the bigger dendrite than this one. Similarly, if it's less than 3, which implicitly says it's more than 10, more than -10. So column 1 and column 2, I consider this range as column 1. From here to this zone, from here to column 2. So I basically merge these two into column 2, which is the same. And then beyond 33 to 100, it's here. 13% is the smallest plate, second level plate, and we have small dendrites. So okay, I think we are good. Crazy and eccentric as it looks, is what it is. Now we gotta assign models to the statements. We can do here. I think can do something like this. Then assign a model. Now, do we do that now or later? I think the tea break is due. So let's run the simulation. We'll remove the rain voice or the sound later to do something more calm, perhaps. So we'll simulate January 1st, 2nd, or the first 10 days. Temperatures will be in the minuses. And it's sometimes possible to recognize the shape of this snow particle. I think we made it. We took a cube. We increased the height, the width. It's tiny. Let's go and look at it. So this is what we first tried to simulate needles. We'll change it to cylinder. Then we decide to go with more cases. So at this point, I think I'm going to either implement all the rest with proper sizes. I think it is snowflake. I was watching a short documentary yesterday. Not going to be a object that is taller than a millimeter. However, since this is a game and you will want to see some familiar aspect, whether snow particle looks fluffy or more spiky, crystal-like. So we could recognize those details. I think sometimes when you see the one of the flakes drop down close to the camera, you get to see that shape. The particle amount increase. Let's go crazy. We might actually have more instances, especially on a blizzard when we snow. I think you kind of get to see that cube aspect. I have seen it a few times. Not sure if it's coming across okay in the stream. I hope it's capturing it. But this is what a real snowstorm might look like. Game. It's like that. I can see the cube shape. So let's do a quick test. Yeah. So instead of this, let's have what can we do here to simulate one of these? We do not have in Blender. I think when you choose cylinder, you could choose the sides. Can we do that here? We need to save this. This is, yeah, unfortunately I cannot. It renders better here, but then I cannot change the aspects of it. Or I lock this. It's a different scene anyway. So when we do these radial segments, let's see. Go 16, 8. We might be able to do this. Okay, this is looking more. Yeah, this is what we are after. Rings. I think this rings is the number of cuts here. And Easy. So the height will be, let's make it 2 millimeters. It's actually 2 centimeters, right? This is 2 centimeters, but scale-wise, I think it worked. Yes. This might be the shape for. We'll see. Maybe I'll consider this as 0, 0, 1, 0, 0, 2, and maybe this is going to be 0, 0, 2 thickness-wise, but I will maybe plus with this radius value. So the height will be either 1 or 2, and then I'll change the radius. Okay, let's go back to this 1. What happens when I do this? Oh, okay, so you kind of go conical. Huh. This is not going to have a visual impact. Let's go, yeah, along the height. So changing doesn't have any visual. Let's keep it 1. 0. 0 seems a possible option, but I don't think it will have a like effect in the render. Let's read that last sentence. I think something important. Maybe there's internal optimization, so I'll keep it default. So let's keep this 0.02. It's going to be 0.02 as well. Let's see. Pause the game. Oh. Okay, something interesting is happening. I paused the engine. This is essentially all the timer functions are frozen, but the shader is still running for particles. Is not affected by. It's slowed down, mind you, but it's not 0. But we get to see those hexagonal shapes. Now the idea here is run full speed. So the idea is how many of these things I can create. This internally I can create. This too, just a larger size, maybe thicker. This is the same thickness as this one, but larger. So that's 3 models done. I can do 3 plates. Let's go here. Where are we? Plates 3 done. Column It's just a taller version of these plates, really. Both columns are done. Needles, it's I will add more edges. So instead of 6, we'll have maybe 12. So that will make it look round. Well, this started off as a cylinder anyway. So this is just a proper looking cylinder. Thinner. And we are talking about marginal changes here between 0.02 and 0.01, maybe 15. So column done, needles done, dendrite 1 and 2 and stiller, which deserves to have its own Blender model. What I would like to do right now is to see if we have some fluctuation there when it comes to these values. Let's pause the game. Yeah, I hit the in-game pause. This is not an engine pause. The game has its own pause. Yeah, I did. Yeah, nothing is moving. Now I'm gonna compare this to values we have here. Something like, nope, don't do that. So move this here. So minus 13, we are here. Humidity 78, so we should be seeing dendrites. My question is, when the temperature is here, sort of here in Toronto, around this date, will the humidity go below, what was my range, 71? That's what I'm curious about. This is usually going to be minus. You're going below 70. Okay, pause. Here's also something funny. Well, because this humidity depends on temperature and dew point, when the weather is warming up, it's also changing humidity. So it's going to be an interesting case to find the perfect temperature range here. Perfect humidity case where we have the transition between these two types of wow, snowflakes. So 68 is definitely in this range, but now we are here. So we should be seeing needles. Go again. So let's look at the clock. This may not be matching the perfect hour. This is correct, we know. I'm waiting for temperature to go down. Anything below minus 10 is welcome. Come on. Running the game a bit faster to see. Fortunately, it's warming up. I'm gonna set it to January 1st because I think we had colder weather in one end. Again. Okay, getting there. There. Just paused it. The humidity is not correct. That's the problem. 17. See, this is just at the threshold. Okay, this is a good case. January 2nd, 7 in the afternoon. This is what's happening. Temperature is here. Humidity just dipped below this threshold. Just going to write that case down. So January 2nd. $1900. Okay, so we should have case from dendrite 2 to stellar plates. We'll test that by pausing the game. We'll look at the general shapes. I'll run the game again. This is good because for the next 2 hours, it should actually stay in this phase. And then around 2300, let's switch back to dendrites size 2 because it just went over the threshold here. Good, so we have this case. We can visually confirm if things are happening. So I will just write one case perhaps. And then leave the rest of this work for some other time. So let's assume this model is, I know it doesn't look like I will call this one stellar. Save this mesh as everything is a model now. It's kind of a resource. Um, I think eventually I'm gonna have to import models anyway. Go into models. Okay. Here I'm going to be a bit more particular. So this is going to be snow types. I'm going to call this since we start with dendrites 2, switch to stellar. So I'm going to assume this is, but I said this is the stellar one. Okay, call this stellar. And then I'm going to make some silly changes to this. I will say this is going to variable like this 4, 3, and make this double the size. Because this is going to be harder to see looking from top, I will reverse this case. So this will be 1, will be 3. So I'll be looking from restriction. So save this as. I hope you haven't overwritten. Okay. Okay. So make unique. This is dendrite 2. So let's load stellar. Stellar. Was what, 6? What happened to you? Pretend we are loading so we can see. Stellar. Stellar is this sort of snowflake with dull corners. So I'm pretending this is going to look this then. Because I'll fix the model later. So what we need to do is dendrite 2 is going to be right. And stellar is going to be we don't do this. No, when you preloaded it. I don't remember doing this. Resource, all right. Instance it. When did we do enum assignments with the... My syntax not correct, apparently. Should I even bother with this? In enumerator, you can't really do. I think what I'm confusing this with is the dictionary. That's I think what I think I did. Okay, that's what I think is. Problem is, yes, all of this will be assigned. Let's pretend it's all this, right? Because we'll fix them later. Soon. Yeah, it's I was confusing the dictionary with the enum because I remember doing something like this, and then it was convenient to write it as enum, and then I wanted the best of both worlds, so it doesn't work. By the way, how are you doing? Long time no see. I hope you've been doing okay. Dendrite 2 is okay. Stellar has to be stellar model. And then we'll fix the other ones later. Let's check our code here. Still be fine. I'm okay too. Busy writing a book and also doing streams. Still urban farmer, long project. Got Omicron during Christmas, so that was something. Cool. So have you been flying around? Weather conditions permitting? Since the date is January 2nd, right? Let's move the date to in hours. Let's say close it. Writing a book? Yeah, I'm writing a book on. It's going to be called Game Development with Blender and Godot engine. It's for Pact Publishing. It should be out by summer. I submitted the third chapter the other day. They will review it. I have to write 10 more chapters. I'm looking at the board here. Kind of learning as I write, and I'm writing as I learn. So one is fueling the other. So it's a good incentive. This bad boy will do. Non-existent function instance in base cylinder mesh. We need that. Something I did do before. Brain is so fuzzy that I think I have the right idea. I'm missing something obvious. So here's the dictionary. Reload without instance. So is my only mistake here the instance? That's why it's pitching. It is. Question though. It's not failing, that's good, but we are not in what is actually happening now in the function snow type. So when we say return from this dictionary, this key, what is it returning? It's returning a resource. It should be so what we need to do right now is we need to access the pass, and we need to swap this resource with the one we want. Luckily, when we say preload, we actually have the resource. So we don't need to instantiate it, because this just needs an instance here. This does its own internal mechanisms, I believe, to it. All we need to do is we need to access the snow particles. Or this is an internal check. So let's just write script. This one, scripts. I'm just going to dump it here for good enough. Default. Spatial is fine. Done. Now, there is actually there is time passed. Time passed. Every time the clock ticks, we could ask the weather system to weather system is a singleton, so right. So get me stuff. What do you mean it's not declared in the current scope? Okay, now it understood it. Snow type. So because we only care for displaying stuff right now versus whether we should display it, we just shamelessly ask for the snow type. Maybe it's the middle of summer, we might still be asking for snow type. It's okay for now. So this is going to return us something. That something will be attached to draw passes. So I'm guessing there could only be 4 draw passes based on this default values. Let me read about that. There's also draw passes. Maybe by default they actually put 4, but could have more than. I believe when you assign multiple draw passes, it we have 2. It shows 2 meshes, 50-50 distributed. I'm guessing that might be an interesting case. Then this is the case where we have multiple snowflakes. We could be doing plates 2, column 2, a good mix. We'll see. Even this was an edge case here. I actually exclude this. Maybe we'll do a mix of these 2. So draw pass 1 is going to be assigned something like, we say, yeah, this is just a draw pass 1. Is assigned a resource. So here goes nothing. Probably either horribly going to horribly fail, or it's going to be a bit. I think something is working. Okay, I have confirmation it's working. And I'll briefly explain. Hard. You see? Maybe those frames are not even coming across. Capturing, I don't know how accurately it's done. I will run the game and I will pause the game. Which surprisingly, pause. Which slows down the particle system. The game is otherwise frozen. This is an interesting case. Maybe there's a bug because I'm expecting particles to be frozen too. Now, particles is using this conical looking thing. VFX models, care for models, snow types. Dendrite -2. This is what we are experiencing, right? As kind of is for most most of our snow types are using this model. Okay. And then at 19 hours, we figured out that it is the right case to switch to stellar. We should have something that looks like this honeycomb thing. Now I will unpause, and then it will go to 17 o'clock. And I will pause the game again at 17 o'clock. And now you can see that the resource has been changed to the honeycomb. I will let the game run for another 4 hours, and then it should switch back to the comical shape. Success. So we are now changing the snowflake shape based on this madness. So depending on the temperature and the humidity, we are able to show different shapes. Hence, we have implemented snow types. The details are, we'll do it later. Which is technical debt. We'll look at it some other time. Maybe some like off-stream hours I'll be doing. So, Ramp, are you still flying, man? We'll pick up again soon, yeah. I'm just curious about like, is it because of the season, like people are not sending enough stuff that requires frequent flights, or is it with the weather? Every business has its own secrets or rhythms like that, which is curious to me. Oh, you're in Saskatchewan. Wow. It's really cold and snowy there. My brother lives in Alberta, and when it's in minus 20s, 30s here, he says it's in the minus 40s or 50s. So, yeah, I'm guessing, yeah, confirm it's the weather. It's too cold. And I'm guessing it's regular practice to do that, de-icing and all that other gadget stuff for the planes to be safe. Antifreeze and whatnot. Just too cold. Speaking of cold, it's cold. Let's actually look up. So it's minus 14 now in Toronto. Let's look at Saskatoon. Maybe you're not. It's even colder here. Assuming you're in Saskatoon. Well, I mean, this is actually putting it. So I think the next order of business is to bind the weather data to snow particles, meaning there's a slight variation here. The speed is not all the same. Since there are too many particles, yes, it's actually easy to see. Enough particles. There's a bit of velocity change here. That's what I did. Yeah, it is. Yeah, you are doing a farming game, right? So weather forecast is. Yeah, I've been working on a very realistic weather system. I have historical data, so I'm working on that. So I guess forecast will be, wow, whatever is in the records for the next few days. It's 2D management farming game. think I remember the interface. And then each page. Let's look at the snow. Let's close this pass. The material itself has the properties. Velocity randomness. So velocity is 15. So they're all coming down. Is this emitting? Why am I not seeing anything? Because this is gray against gray. Luckily, we look at this separately. Even better, this. Directly on each exporting HTML from Godot. Relatively simple. It is actually, yeah, relatively easy. If you want to put your each page in the stream chat, I will show it so it's, it's good. Like, I don't mind. I do mind when people post weird URLs that go to questionable places. Yours won't be one of those. Teach.io. I may actually have it in my followed accounts, but I always have a hard time finding it. Followed dashboard? No. There are a bunch of itch pages or accounts that I follow. It's always hard for me to find them. Say dashboard. It's my own dashboard. Right in the middle. I guess I missed it. Fuzzy fields, yes. On this game. I do remember, yeah. Last year. Fuzzy fields, yeah. So people are interested in Godot, go check it out. We play it in the browser, so it's good. Let's help each other out. There aren't that many Godot games out. I will actually put this in the chat, so there's a record. People might click it. In case they don't hit this part in the stream, it will be part of the stream chat. Okay. So now that we have this prototype here, I can change the particles properties of the particle. So this is going to slow it down. Make it 1. Yeah. First, it's waiting for existing 50,000 to finish. Here's what's happening though. You see the shadow of the particles. The emitter is somewhere around here. Okay. So they are falling down. I believe they have such a short lifetime that with this velocity, they never have enough lifetime to hit the ground. If you look at this particle going down, it disappeared right there. Let's have a more horizontal look. Because I adjusted the volume to hit the ground, it's not coming down. Sort of finishing perfectly horizontal. Yeah. This is how we can see the lifetime versus velocity. Now, let's change velocity to 2. This section is still the initial 50,000. Now the new particles with velocity 2 are catching up. They come here. You're welcome, man. Most complicated part was coding the download and upload of a save file on the. If it was a PC game, yeah, you would have to worry about the person's folder, the file system, right? But there are reserved paths for that in Godot. If it's HTML, where would you be loading them from? Interesting question. So we have snow. Velocity 2. Let's see what it means. As far as I recall, this height, I don't need to recall. 30 units. This is 30 meters. Time for some physics. On PC, it's, yeah, user. Yeah, in the HTML case, the user is the browser, but then also which browser, right? Yeah. So let's look at this page. There's local storage and there's session storage. Those are storage options. This is actually very commonly used. I know. Problem though is if you play the game in this browser and you switch to Firefox, the local storage in Chrome won't be shared, so you will have problems like that too. So another case is that your game has access to database like Firestore or some other cloud database. Could still be a browser game, but then you keep the save file somewhere else. Now you could play it browser agnostic. But that's a lot of work too. So from here to all the way down here is 30. Let's the fact that we set this to 0 yesterday, questionable. Set it. Because what I would like to do is should be 0. What was that rule? 5, 15, 25. We consider this 10. So in 1 second, particle here will come down 5 meters. Between the first and the second, surprisingly, it's going to travel another 15 meters. So over the course of 2 seconds, this will have traveled 20. You have to go and eat. Go, man. Enjoy your food. Thank you for the wish list. I think I'm going to grab more tea and do some physics and particles. Oh, let it snow. So let's arbitrarily set this to 0. So now all the particles are generated here. They don't have any speed or velocity to come down. This randomness is then meaningless. Okay. I also think what's happening here is it was obvious when there was velocity that the this rectangle here is only sort of like the word. There's a volume there, but we only see it from one axis. So normally the particles should be contained in this area, but they are spread. There's like flow over. And if I recall, hey, how you doing? So I did that thing from yesterday. This is done. It's working with 2 simple test cases. I'm now moving on to the next craziness. Did you figure out the alpha issues? It says talked about spread here. Direction comes from spread and denotes orientation. And bunch of time getting one enemy walk animation. Blender work or Unity animation system? Spread 10. Let's zero this in. Volt 45. Lots learned. It's always good. Let's change this to 0. See if this flow over part gonna disappear. Assuming the cube is there, right? Huh. Let's reset this to... Where are you? I'll let it do its thing. Animation keyframes get optimized. Ooh, non-changing animation is no. That's interesting. Lifetime is actually set here. This is lifetime randomness. So Okay, let's not fuss with this. Go here. The T pose. Yeah, corks. That's what I'm going to look into at some point. I did a few basic test cases. Blender to Godot animation export. Everything worked just fine. Guessing maybe if I have more advanced cases, I'll also hit some difficulties too. But we'll see. But we don't use FBX. We have our own format. I don't know if it matters. But I think I know exactly what you mean. That's like you. It takes the first animations, first frame, like you said, as the pre. Hit a button, make a game. Still see some Facebook posts. People say, I need a game. It does this. Someone working for free. How hard can it be? Just push a few buttons. Luckily, we are not in that club. Bulk animation. Yeah. It's a great deal amount of work. So let's zero everything in if possible. No damping, no dumping, nothing. You don't dump here. Okay. Whoa. Okay. None of this. Gravity is 0, which I arbitrarily set it. This is actually, it made sense when this was minus. We'll switch to that. Right now, let's actually turn this off too. They are disappearing after 10 seconds. Let's also make it 2 seconds. I have a feeling I'm gonna have to try a lot of things here. So particle just appeared here, 2 seconds, gone. The button is in inspector on the second on the component, so select enemy, punish them with roll toggle. Huh. It sounds like you're using a inspector, like custom editor, custom inspector. Forgot to name the you introduce buttons into the inspector. Every 2 seconds we have these things changing. Let's test this spread. Also, let's change this direction too. Emission direction. So since they have no speed, they cannot really go in X. So normally they should be coming towards us because let's give it some basic speed. Yes, they are coming towards us. I see. Yeah. Hello, DM of Skulls. Yeah, affecting those the children automatically, that might be a good thing or a very bad thing. Hitboxes, and I think you mean collision boxes, right? So this should definitely be, this is going to be 0, this is going to be, interesting. Why is it flying in this direction? Each particle's initial direction range from plus spread, so plus 45 to minus 45 degrees. Do this. Let's get closer. We have the emitter. I kind of see the 45-degree business, like from here, here's the 45. Something that is generated here is coming here. So if I narrow this angle, then it's not what I expected though. We have a few loose ones coming up, but I am a game developer, yes. Catching up with the chat, let's see. Yep, I'm currently developing ambitious farming simulation game. Right now I'm working on the weather system. We could have pretty looking snow. This is horrible looking snow right now. Weather luck. Fertilizers. Blue arrow is 0. Spread is deviation angle for. Funny thing is, we have XYZ here, but the spread is not sort of one value, but when I set it to 90, it almost looked like coming down, but this is actually interesting because there's this natural spreading out effect. If I run the time, this is actually taking longer time. Go to the game, we will eventually see something looking a lot more like stuff flying around. This is interesting because this is stuff is coming down, but when you look from this perspective, some stuff is flying upwards, which kind of looks like this. This is the stuff that I was trying to create. This turbulence thing here. Sometimes stuff looks like it's flown up upwards. Let's see, it looks horrible. Yes. Spreading angle. Urban Farmer is my game. Yes. There's a Steam page for it. I would really appreciate it if you go and wishlist it. So you could also get the updates too. I post devlog updates on Steam once a month, more or less. So that would be like the official channel plus the streams if you catch them. See, the thing with particles is there are too many variables. Sometimes you get a nice effect. And this is definitely something that I actually wanted to do here with these different shapes, which may pay off because if some of them are flying towards you, you really get to see their shapes, which is cool. It's not going to be this big, of course, but they look flatter. They might actually. PC not working right now. Well, hopefully by the time the game is out, it will be. I mean, for your own sake. Yeah, the variation will be the wind affecting it. This is kind of a wild case, so I'm going to reset this to default and see what happens. And this is still going to take 10 seconds to start the next cycle. So what we see is still the particles that were created 10 seconds. Wait, and it will clear up. It's crazy, still going on. This direction business is also weird. The one. Yeah, I'm going to change the time to 2 seconds again because it takes too long to reset. It's not really in this case. Yeah, they will eventually be smaller. I did it so that I could see the difference between. We have this shape. I just made them a bit bigger so I could see them here. Eventually, they will be smaller and many more shapes. Something that actually looks like. So here's something interesting I'm seeing. When this is all 0, actually no, this is x1. Okay, now this is making sense, kind of. I bet if I looked at it from this side, yeah. So they are flown this way. So in the x direction 1 and spread 45. So they spread 45 degree this way, 45 degree this way. So now I fully understand what it means. So this should normally be, let's say, 0. So then they're only going x this way. And of course, this is never going to be x. Well, depending on the wind direction, we might actually have something like this, but never 1. Or let me make another correction. Never 1, 0, 0. We should have something like 1. It's 1. So, okay. This is without the spread. 1 in the x, 1 in the. When I say y, I actually mean -1. So like down in the y. So this is sort of the 45 degrees using the coordinate system. So this is going to be fully down. -1. Now to simulate the wind effect, if there is wind coming from this direction or from this direction, we will do it this way. This blown from right, or the wind is changing direction. And also we will incorporate Z too, so that we have the other angle. This is the reason why I'm probably never going to fuss with this. Okay, I'm going to change just this, just default this. So now this is affected only by gravity. Now if we change this, here's sort of the wind. This is too much. Ah, gotcha. Okay. Let's catch up with chat. I've been catching up on the direction stuff you guys wrote. Yeah, there's going to be some stuff here. This stuff. These four guys are going to be responsible for pushing the particles in different axes. Try. Sorry. Try. Okay. What? Try what? You're gonna head to the bed? Okay, cool, man. So see you later. If I use gravity, you run into false speed acceleration. Okay, let's look at this in right now. Okay, they never come down. They don't have enough lifetime to. They only spend 2 seconds to live and die. So yeah, you suggest I don't use gravity, but isn't that the natural thing that you turn on the gravity and does its thing? Because if I don't, then I have to depend on other settings to simulate the gravity. So my question may be, why do all the hard work when you just turn on the gravity? Why do a lot of work to simulate the effect? Because then it turns into even a bigger guess game. So I'm guessing your explanation is suggesting that gravity is sort of like a blanket assignment. You want variation for the particles. If we add gravity, that's like constant acceleration. I'm thinking. You're saying set this to 0. It has to be, of course, -1 because thing will happen. The x's are now all 0. And we have to change the but see, this is just a shortcut method. Like if I put 10 -10 here, actually no, if I put -1, if I change the velocity to 10, this is the same thing as let's try fully what you're saying. This one, set this to 0, and spread will be 5 degrees, you're saying, and velocity will be 1. This is, if you look from here, it's going to you don't actually get to see that 5 degrees like this way and that way. If you do it this way, then it's of course 45 degrees. Yeah, so it's actually 45 this way, 45 this way. This is more straight, and if this is 0, then everything is coming down straight. We change this to 75, then they just spread out too much like this. This is like a flurry. Then after that, you tweak list options, just a slight variation. After that, you want to effective. I think I might, give this a try, because depending on the wind speed, if there is too much wind, I will most likely have this close to 0. Then I will be incrementing something like this, which actually gives this directionality, right? This is like the rotation, the wind direction. And if the wind is blowing from this direction, it's going to be looking like this. If wind speed is slow, then I will increase this to have a calmer drop. The only problem is the lifetime is too short. It never even reaches 1/3 of this total volume. Let's see what this is doing. But see, I don't want to randomly do this. I want this to be affected by all this data that I have, which is, I have real data. It should kind of make sense, because I'm displaying this to the player. This, the speed and the direction. Yeah, so let's see what it actually does. So this is -1 for sure. This is, let's assume this is 0. Spread back to 5, which doesn't spread much. It's very light spread. Then never going to fuss with this. What is this doing? Initial angular velocity applied to each particle. We don't see any change from this axis. Angular velocity randomness. Okay, I'm trying to catch up with the messages and then what I'm looking at or what I'm changing. Where is the update related tweak values? Yeah, this is according to the explanation. There is initial angular velocity. So yeah, when it's generated, it's sort of maybe push this way. Let's change it to 2 and then see. These values might be too small or too inconsistent. I don't quite know. Okay, this velocity 4 definitely speeding up. Changing this doesn't do much. Let's change this to okay, in my opinion, this doesn't do shit. Close it. Mouse over each axle. See if I'll say it's initial. This is an initial. I actually saw this yesterday. This works like linear acceleration. This 2 radial, and then the tangential 2. So these 3 are working constantly on the particles. This is the only one that is affecting the initial angular velocity. So this I don't think this has any the effect we want to create. Now this linear acceleration applied to each particle in the direction of motion. So this is initial velocity, and this is like after it is generated. So if we have set this to 1, actually let's just do 4. I think it is what's probably happening is don't really have a good frame of reference here, but I think I noticed some difference. Like they started velocity 4. Let's make this 8. Yeah, they definitely speed up. So if I have this, I don't think I should bother with this. This is like when, like to simulate, if suddenly there's like wind force, you suddenly set this to some high value, like suddenly you do something like this. Looks like it's picking up, and then you reset it to 0, and then things slow down. Because this is affecting everything initially, by the time something that starts here all the way like falling down, the initial velocity will not be seen by the camera. But this though is affecting the visible ones too. So this is only useful to have that wind effect after the fact. So you're saying set this to 0. Still random linear acceleration. This one or just some random number? Yeah, this is not going to do anything unless this is other than 0. I think this is what I'm seeing is happening. We will definitely have initial velocity. So I have initial velocity. Okay. I think that is just going to be some arbitrary number that I did. Good enough. This is going to be the standard case. And linear acceleration is to simulate wind bursts. Like gust what it is. Look more from side because that is where you'll see the change. Yeah, but we need the initial velocity for the standard case. I'm okay with that actually. But I could also have initial velocity randomness too. Maybe we'll ignore this and we'll just go with these three. But right now, I think trying to get a standard sort of case down. No, actually, we assume it's always coming down, right? But then we also said this x should be changed depending on the wind direction too. Well, the goal is that I don't want to play with too many things either. That's because I already have enough complicated case. So I actually set this even to 10, like to see the difference. Doesn't make any difference. I think the intensity of this is really not making any difference. It's just maybe they take like the normalized value. As long as it's minus in y, it's fine. You could have this, but if you have this like +1, then it's gonna go upward. Well, it was trying to. And then it didn't. Yeah, it's gonna be normalized, but I'm also surprised by this too. Because this works. Say x1 and then y0. Actually, even this doesn't work now. What is happening? Because earlier we saw everything flown this way. Something is not quite right here. Let's cancel this. Let's also have just this initial velocity 5. Okay, see this is this is the scary part. I think we do need to have initial velocity. That's it. When that is 0, nothing happens. Things just appear on that plane and they disappear. They don't go anywhere. And then if we have this linear acceleration, they just tend to go down. I guess there are some internal mechanisms that think that this should just be affected by, even though gravity is 0. It ignores this x1. It thinks there is y minus 1. Everything is 0, gravity is 0. I think this is making some assumptions that when there is no initial velocity and there is some linear acceleration, it tends to go down, which is scary because if this is unreliable, then I'd rather have this because I can't control this. This is 5 only in x. I can't do this. It's 1. Now we know for sure this is coming down, and if we say 1, it's gonna fly up. The question, of course, is this. We change the magnitude here. Is it going faster? It shouldn't. This speed is not changing by the magnitude. It's normalized. So just the directionality is important. That's it. Yeah, I think this is important. We could also, of course, do this. The velocity randomness. That. Okay, initial velocity, it's a given. Linear acceleration for wind gust. Can we now rely on this? I think we can rely on this. So suddenly there's wind gust, or this is actually reversing it. Between 0, 5. Okay, I will use linear acceleration for sort of push down effect. How about this? That's actually sideways. Question though. See, when it says 5 here, this is about acceleration, but there is no discussion about direction. All of a sudden, it chose this direction for the acceleration. Why is it not going this way or this way? Again, this thing I think is since this is here, we can always look here too. Now it's always coming down. And it's just changing. So once again, this is perhaps a much better. Oh, I know it's going this way, and it's gonna go away from us. If I do -1, it's going to come towards us. I can control it here, the direction. Since it's random here or unpredictable, I cannot rely on this either. Because minus is ooh. Just notice something. When it's minus, let's say 10, exaggerated. Yeah, it's supposed to make it go around. The thing is, when it's minus 10, it's as if a particle that starts here is normally falling down. Something that starts here that's supposed to fall down, it's trying to rotate and sort of like converge here. When it's positive 10, then it spreads out from the center. Yeah, which actually is explained here. Makes particle accelerate away from origin. We do not want this. We definitely do not want this. Yeah, it's either coming to the origin or going away from the origin. And to simulate this, we don't need that one. To simulate what, you might be asking? This. We could simulate this constant wind blowing things this way. We could already do that. There's the second effect of turbulence and some surface here blowing stuff away. That will probably be done with shaders anyway. So the question then is, we already have the case where things are coming down. It's a simple case. Can we now depend on randomness and create this sort of like gust effect here as well as this dropping effect? I think we can, because we already figured it out with this. This is the gust. And by some clever X and Z changes, with the linear acceleration that actually simulates the gust, we can do this. So don't touch radial acceleration. That's not I'm taking. Radial acceleration, a big no. And that's the gospel. So yeah, we don't write do radial here. Tangential is perpendicular to the particle's velocity, giving the particles a swirling motion. Now this is something interesting sounding. So let's try. Now everything is just coming down. It's -1. Slight spread 5 degrees here and there. Zero acceleration, so no gust, some gust, no gust. Everything is fine. We said this was also useless too now. Tangential. Oh. Hello. Donuts. Go round and round. Here's the volumetric turbulence. Done. This is what we want to see. Of course, the particles don't have enough lifetime to come down, but now let's center fly through this. This. Enough randomness. Can we go over 1 here? This is indeed interesting. Everything is calming down. So here's what I'm going to do. So when it's going sort of 15-ish, right? Here's what I'm going to do, something crazy. Let's just turn this on. I'm curious. Under normal conditions, when they were all coming down, now we have turbulence. What happens when we turn this on? This is what I'm looking for. This force coming down, like pushing things in this way. Now, if we can control that, then it's awesome. Now, because we have gravity and things are pulled down a lot faster, then even though the lifetime is short, we actually get to see it at the. Now, this is probably counterintuitive because it's hard to control. But we have to compensate for this. I get it. Normally, I want to change fewer things. I just want to see it. The acceleration curve is you assign this curve texture, and this is you have presets here. You can have easing functions. So if it starts to accelerate from here to here, it's going to start slow and then go faster and faster, and then depending on this curve, will have different effects. Like this one is, let's just simulate really edge cases. I thought we had presets here. Right click. Okay, load preset, linear. So this is linear. I think this was the default case. Right click, load preset, and let's do ease in. So this is different. Let's do ease out. and the behavior changes. The speed never changes, but then yeah, the behavior changes. Have clear, yeah, I can clear it. I think so. Yeah, the curve might give that turbulence. I could assign some number here and the right curve. I can even actually do that for the linear acceleration, which I said for wind gust. Let's reset this to 0 and this too. This could totally be a Godot bug. Even though these two are 0, why are you still... See, that's interesting. Look, even though these two are 0, it's still considered this. Yeah, it still does something with it. Problem is, yeah, I think even though I would expect this to be a multiplier so that whatever this is not affecting anything. Now everything is even like flying up. Yeah, this is sort of scary to. This has to be cleared at some point. It's either that clear or this clear. As long as one is clear, it's fine. Expecting the expecting things to work the way they should, yes. Half the IT world is making their money that way anyway. Right? By fixing what the other IT guy built. Or pick up the phone and at least say, did you try to turn it on and off? Which often works anyway. So tangential acceleration without the curve. What did we gain from this exercise? Turbulence. Although it's nice to look at, can I eliminate this variable from my calculus? Because I already said I'm going to simulate the wind direction by doing this. Might be nice to have this sometimes. Small value maybe. Angle might be interesting. Which angle? This angle? I'm putting a question mark here for tangential. So let's rule that out. Maybe for flavor. Because if I don't write this down tomorrow, I will have to rediscover all this. So initial, guaranteed. Angular, don't bother. Linear, sure. Wind gust. Radial, we don't do radial here. Tangential for flavor. There's damping, we skipped, and you say we move on to angle, or maybe we look at damping. Damping or dumpling. Yeah, tangential, as you pointed out, it kind of goes both ways too. Sort of like we So this is kind of a close-up. Okay, this is more like what we'll see at ground level. This is tangential 1. If we say 0, what does it really add? It's not predictable, because if I increase this large enough, sort of flies everywhere, but not in a controllable way. I'm putting this in no zone too. Okay, it's the no zone. So, I angle might be nice, but depends on how it's implemented. Let's see. Let's read first. Initial rotation applied to each particle. Along which axis though? Let's just set this to 0. Now it's all coming down. Perfect. Angle goes by 2. I think it might, because rotation is something, I won't need, because things will just... when something is starting way up here, then it's going to take its time to define its sort of its path. Who cares if what the initial rotation is, right? Nevertheless, I'm going to increase it. And we don't see shit. Let's see if I look at the volume. Nope. Angle is gone. Angle is no zone. Let's look at damping. The rate at which particles lose velocity. They are dampened. Yeah, I was thinking it's not really suitable, right? Because we want to display things. We dampen them. What does it actually mean code-wise? Or how is this going to relate to the dampening effect? So conditions are okay for snow. So we see stuff coming down. So suddenly there's dampening effect. But who cares if we just change the conditions anyway? We turn off the emitter, or we change the particle number, we change the velocity, whatever. So kind of like dampening anyway. Right? Bye bye. Damping plus angle gone. Dampen to 1% off initial. Does it even work? I think this is speed, not 1%. It's not percentage based. 99% to dampen. So the speed is 5. So you're saying like maybe, I know 4 is not 99. It's like dampening too much. to the point that they are created, they tend to go down, but they can't go anywhere. They appear, they disappear. Every 2 seconds, I look at the particles. Yeah, must be speed lost per second. It is. It's the velocity. Yeah, the rate at which particles lose velocity. They don't lose speed at all. We are going to affect their speed by changing the speed. So at some point there won't be favorable conditions and scale. Now scale is one. Let's do the randomness. This scale will be important for 2 reasons. Let's run the game and I'll pause too quickly. Again, pause too quickly. Let me change the time. Okay. So some of these shapes, when of course I do the whole assignment right, I think we'll have 8 different shapes. Some of them have been marked as this is like 2 sizes. This is again 2 sizes. This is 3 sizes. I think this is when I can get away with one model and I'll just change the scale. So I assume this is type number 1, type number 2. So I'll assume this is scale 2. And I'll maybe make this one 2.5, something like that. I marked it as 3 here. That's what I could do and get away with instead of like assigning dendrite or plate 1, 2, 3 resources. The animation is what? What animation? Looking at the clock, a few minutes ago, you wrote animation is what? What animation? In the system, you assume it's just for animating the particle. Velocity over time. I'm not sure if actually a message didn't come through, but interpreting what you have written. So the particle system is creating shader. Animate velocity over time. I think we are talking about the same thing. Oh, this animation you meant. Now I'm actually seeing this. Because I was talking about the scale here, and then you said animations, and I thought like I'm not really animating anything, but this is all being done for me. So we could actually change the scale randomness. We can already see the effect. We have tiny parts and sort of larger parts. If this was 0, then they're all going to be same. Of course, the lifetime is 10 seconds. We have to wait the full 10 seconds for everything to reset. Is it per particle? It is per particle. Yeah, when each particle is generated, its scale is randomized. Except after 10 seconds, I don't really see anything change, which is constant. Initial scale applied to each particle. This might be not scale, you meant animation stuff. Particle animation speed. I don't know, let's change it. Actually, let's go here. Click this. Let's also change the time back 2 seconds again. When things take too long, then we don't actually see the reset quickly enough. So now, yeah, I think the scale is now fully fixed. I can confirm. So the animation speed, this is what you wanted to see. What is this doing? I don't see anything change, unfortunately. Particle animation speed. That's kind of what it says. Like, doesn't explain anything, unlike the other properties. We get decent explanation for the other ones, but this one is. Yeah, changing anything here in the curves, randomness, the speed. This had zero impact. Interesting. Okay, I guess we'll ignore it. Don't you get tilted when mousing? No. Don't. Yeah, I don't think that they let you do that. Like, I think this is like title. It's self-explanatory that this is where you'll adjust the initial velocity, and then the properties have their own hints. The group itself, they don't have hints. Yeah. The scale, I'm writing it down. That might be important. So we just found out animation is sort of useless. My only concern is, let's say, let's do 50, right? I'm going to run the game. And because I set the lifetime to 2 seconds, stuff is appearing here. In 2 seconds, it dies off before we get to see it in front of the. But looking at the shadow, does this look like animation is 50? Does it actually have any impact? Set this. Nope, I see the same thing. So I will assume it's trying to do something, but we don't really have any way to confirm it's doing. So color, well, this is just a tint. Hue variation is I don't think this is relevant either. Just change this color in a weird way. Yeah, because I'm loading a spatial material, it's affecting its own color, which is defined in the particle system, not the material. But if I set the material there so that its vertex color use this albedo, if that was set to true, then this would change it. So we could actually do that, which would be here. Close this, this. This has a default material which is actually empty, so it's using the internal material. So I can assign a default one here, and then I'll do the this one. Okay, now everything will be red. So it needs to be assigned although default, a custom spatial material with this flag on, so that it could be assigned. It's kind of the shader overwriting this vortex. So now this can be blue, green, and if someone pissed in the sky, would I guess snow yellow. Don't piss in the sky. Or maybe it's just bloodbath. That would be something. Being orange. I guess if the game is going to simulate an industrial area where urban farming might be, I don't know, a life-saving activity, to simulate acid rain, maybe we'll have colored snow like this. Who knows? I think I'm going to take a dinner break. Won't stop the stream, but the stream will go on the break screen. Come back most likely in 20-25 minutes. So see you soon. Let's turn on the music. So welcome back. So it's still snowing orange as we were changing the color of particles, or more like the 3D models. So we made a black change in the spatial material. So this is not something we will use, most likely. So I'm going to go here and unassign the material. Should be fine. Let's save it. Is emitting? No. So back to the original color. And hence the hue variation is not going to matter because I think this is a variation on the color. Animation, we noticed there was no change at all. Scale, we said it's going to be important for switching between these multiple cases for a particular type. And then I think we are done here. So of course this lifetime randomness might be a thing. But okay, we haven't investigated anything about direction. Flags. Let's see. The line Y. The direction of its velocity. I don't think this is important for us because we are already making this. Yeah, we looked at this angle. We didn't notice any changes. That's because this flag is not. Even then, the initial rotation. So this is basically defining how like rotated the things. It doesn't matter because our shape is so. Imagine a sphere. If you rotate it around its y-axis, it's still going to look like a sphere. It's not going to matter. Yeah, we don't want any of these because this is all going to be affected by the wind direction and speed. So the shape so far. This kind of changes everything. This kind of changes everything. Okay. Let me tell you why this is kind of concerning, kind of irrelevant. Yesterday, here, yeah. So I was playing with these values. This is drawing volume here, which is shown here with this yellow lines. So there's some cube enough. You could change its handles. This was, I think, position of the cube. So the discovery was that when the camera is raycasting, and if it hits this volume, it changes the emitting property. So that way, no particles are rendered when the camera is not seeing that volume. So in essence, this is kind of a collision shape. What was surprising yesterday, which now is answered, is the volume that the particle system is using to fill the basically generate all the particles in that volume. Now it just coincided that these values were pretty much the same, so that's why it always looked like it was filling this yellow area. But now I know because whoever did choose these values before me picked them, I guess, carefully enough that they kind of coincided. Now yesterday we also found out when this position is here, it will still yeah, right now that visibility cube is here, but this is the area the particle system is filling, because that's the new discovery. It just happens to be this. So this is an area starting from here occupying this space, whereas the visibility cube could be anywhere. This could even be here. And you'll still have the particles here, which is interesting. Set this to 0. So as long as this box is large enough for the camera to hit, I think we'll be okay. In fact, I'm going to make this box large enough so that it's not going to be in our way. I'm going to make this something like this. Of course, this has to be centered. Okay. The camera will never be this high. It might be, but let's also make this. In fact, since this doesn't really matter anymore. Which is good news, because previously I was having a hard time visualizing this, and now I can do things here. So this doesn't matter. And now this might be relevant later if I have rendering issues. This is okay. Now let's switch to this. Now this is a different story. You say 1, you are going to have a very narrow area. This is like one of those features that you see at restaurants, like the waterfall or water wall kind of thing. Now this is a different story. That yellow thing or the visibility cube is now here. So if the camera is facing this way, particles are not going to fire. We actually tested that yesterday. Because this is a large cube and we will always be inside, so this is always going to fire. Now how much box extends? Let's see. Ring. Shape ring. Let me reset this to 0. Sorry, 30. This is like a spray. Sphere is I can actually see the. Let's notice something. This is where the brown plane cuts off the sphere, so you don't. There's an empty area here. It's as if we are inside the sphere and only the outside of the sphere has the snow. Like, see, I'm kind of in the sphere. So only you look at the sphere from outside, you get to see the experience. You're kind of inside the sphere. You get the far sides, but there's sort of like a near clipping plane. You don't get to see the near. So let's do one. I don't really see anything change here. Let's see. The axis of the ring when using the emitter shape ring. It's a shape ring. Say Z1. Okay, the ring is, I see, it's a ring like this. Whereas Z1 here, 0 here, going to be a donut like this. Except there are too many particles here, that's why I don't see much. Let's go to here and say 1000 is maybe. Has to wait for 10 seconds to finish its lifetime. Or 2 seconds. So it's as if there's a ring here, and this actually acts more like a circle compared to a sphere. So now when we increase the radius, we don't have that clipping problem with the sphere. However, there's inside radius. We increase this to this and this to this. Fortunately, the ring is too small. Let's do 12 to 2. And if we increase this value to 8, so this is like a donut shape. It's kind of whimsical because it's like, wow, just above my house, nothing is happening. And this is the height. It's like a column of snow, except the inside is hollow. Interesting. And this is the axis, so it's only going in the y direction. The point was just 1 point. Say points, I guess you're assigning a array and point count. Create emission points from mesh node under the particle. Yeah. Particles tool in the toolbar. Should be here. So when you say multiple points, you could designate a few points and it's going to be in from there. That's an interesting case. Maybe we'll look into those cases when we have water features in the garden to simulate watering stuff. And this is a similar idea. So I guess we can either go with ring with no inner radius. It's going to have a circle, or we could go with the box. Look at the box. Can we see the extent of this box? Sort of invisible. View gizmos. I would expect this to be 32 because I put my emitter. This is just the particles material itself. I put this 30 Y. Problem is, let's look at it from see some snow. This is the particles object. Adjust it so it's has enough contrast. See, when I say box 15, it comes all the way down here. Of course, this time lifetime is also a factor too, but let's do this 5. I see. So this is 30. Make this 30 as well. So 13.4. An interesting value there because I want to bring that particles object down, but just above the clipping plane. You know what I can do? Maybe I should do that. View this. Wanted to open two scenes next to each other. Cannot do that, can I? Um, kind of do, but it's not part of. So in other words, it's not practical. So I'll have to go in here to bring this down. I'm going to assume this is 15, which may not be. This is sort of the camera angle. If I do this, particles, okay, so I could go even lower. So let's say 10 meters. I will keep it 10 meters maybe. In a different mission, if the building, the house is taller. Let's keep it 13. Which now means that I can. This is not the constraint I'm looking for. This is the constraint I'm looking for. This could be 13. Okay. The X and Y, it doesn't matter. We'll maybe change them later. Right now, 13 is it's starting here. Yes, it should. Is this doubled? Like, should this be 6.5? I think it had to be because I'm not expecting to see that many particles, and this is the case. If this is 13, then we get to see a lot more. So like from the center, you go 13 in each direction. That's so then this is really maybe 2. We'll see. Because if this is the neighborhood, you'll have another house's backyard here. So this thing going as far as here is 30. That makes sense. Perhaps this 13 is too much because now you have snow here. Something else I'm noticing. Surely this position matters, right? In the X, I'm going all the way here. In the X, so we should either have the snow here or here. Which is it? Thing is, when I move that particles with the visibility volume, it's about raycasting now, right? Is here. Whoa. Yeah, it's snowing here. Why is this scale off? Okay. Where are you? 304. Okay, that's 800. the scale is way off, so yeah, that's more like it. Okay. Is it snowing here? I see particles. This is running fine. So it's safe to assume that the 13 is extending both ways. Question is it extending from the origin of the particles? It is, I think. Yeah, it is. Because I see some stuff here, and then below this level too. So here's the house. Let's bring the particle system back to its position. Let's call this 14 so we have a somewhat round. Here we'll do the extent maybe 7. Having this something crazy, let's see, 70. So now it's trying to use 1000 particles to fill the bigger box. When this is little, and the problem with this one is that the box is small, but it's very close to the origin of the particles. The camera is kind of away because this is all happening above the house. So up, you actually see this box extend to you. It's like 60 by 2 by 60. This is all happening in a very narrow area. You can actually see that by exaggerating the number of particles. Let's do that. So let's have at least 10,000 particles. Kind of get to see this box extends to. Going to change this to this, even narrower. Now we exaggerate it and we make 30. See some stuff starting here. Okay, I'll keep this as 7. think I understand the difference between this one and the ring. It's not just the shape, but the ring also had a different behavior. It was as if was it going both ways like this box extent does? Because this is the question that I'm asking myself. The reason why I positioned the particles 14 meters in Y, so that it would be high enough that the camera would not sort of see the creation of the particles, right? Would look awkward. So they would have enough time to land and go right in front of the camera. But now what I'm understanding is this 7 is the reason why I picked 7 is because this is 14 meters above the surface. So then I would actually half it, would use 7 and another 7 to fill like 14 pearl height. It's not like this is the center of things, right? But then it kind of acts like the center from here. It's as if there's another 7 here. But that might just be a perspective error because all the particles that I see here are part of this volume. Like this is not necessarily above this level, sort of farther away. So I think the best way is to look at it from the side. So this is 14. Where does 7 come into play? Like, are there particles here that we don't get to see? This is happening because of see the camera. I think we do have that sun thingy, right? This. So let's change this color to black. Gotcha. This is what I was suspecting. I'm kind of centering it over the horizon. So this is 14. When I say box extends 7, what does it mean? It's the horizon color. Yeah. Zero. It's 14. Let me double check before I some stupid mistake. Okay, 14. This is also set to 0. Which gets imported into this area, which is also 0. And environment is also 0. And environment here is also 0, right? So this is truly 14. Now, about local coordinates or not, this one, this one. Did that make any difference? It's about the drawing box though. The raycasting thing. Doesn't impact this. Okay, so go change it. Let's say 1. New grid. Can we open the grid for z-axis? If you look at it from the top, maybe. So this is 1, 2, 3. So each one of these large ones. 1, 2, 3, 4. There's some setting about this, right? That's grid map. This is primary grid steps 8. There you go. So it's 8 meters. 8, 16, 24. Would be 32, so it's 30. So yeah, confirmed. So this is only in X direction 30, and then it considers another like minus X. It's doubling. Okay. So now when we go sideways, this one it means 2 grid sizes. So it should actually be like 2. And I think I see why. You consider this the origin. Some particles are created here. You can actually see if you wait long enough, like this one, just create it, and it spends 2 seconds and it dies. Okay. Then here you see some start to, and then they die in 2 seconds. So that solves the mystery of your box extent. Now, question you might ask, then why the hell do we have all the rest falling down? That's because of this. Because the ones that you see that are generated, they don't really have that much velocity, so they kind of spend their time hanging out in their original box. The other ones, they have. This is probably screwing it up. This ratio, I don't know, like what 1 means here. Like how many? What's the multiplier here, right? I bet if we change this to this, then everything that actually starts has the constant 5 meters per second y speed. Right? Now everything is still is generated in this two boxes or 2 units. Box, okay. Wish they had a gizmo for that, but I now understand. So it's going sort of both ways. Which is interesting because if I want these upper level ones start at 14, I have to take this down to 7. Still keep this 7 box extent, which will recompensate. So then things will truly start here as this being like the 14. If I put 7 here, then I'm essentially have 21 effectively. Which is why I think I might have to switch to the ring. So ring, we don't have this. Height is, let me get it down to, does this function the same way? 1. It's still offset sort of. Get this down to 1. Check this at 5. So this being the same, 12 or 1. Of course, for this, see now this is fully 12. Wow, not really, it's radius, so make it 30. I'm more interested in this aspect here. If I switch to box, automatically I see this being the same one. Sort of snaps here. This being the upper one, this being the lower one. This height one, it's like half here and half here, total 1 here. Whereas the other one kind of means 2 here. Say 2, and it's going to be the one in box extent. Okay. So where do we go from here? Which one feels true? Imagine we still have the same, if you consider the edges here not occupied, regardless, it's more or less the same volume. Which one feels all the velocity conditions considered the same? Which one feels this? There's a considerable difference. The box's volume is larger, and since it's trying to occupy a larger volume, 1000 particles, it doesn't feel dense, and it's as if they kind of slow down too. Doesn't make any sense according to this, but do you look at it? I will go with box. I will make this change 7. I will also make that change here 7 for the so that the box extents can be properly figured. Okay, and then the reason why I'm doing this is because if this was an experiment, or like sort of like we are trying to write down the equations, we would consider this volume to be more a cubic shape than the ring. And looking into the distance, I'm pretty sure our minds would comprehend this sort of like if this was a ring, it would not be snowing past a round edge like this. You could still kind of see it because a lot of particles are in your way. Technically, it would not be snowing in this, over this area. And now that it's snowing, it'll probably add to the depth. So we would like to see that perhaps. So, and then simulating it this way, not only does it sound more realistic, but I at least need a base case. Now, whatever happens here is a separate concern. Let's remove those. We only have the XZ grid. Let's check the stream goals, see. So far, we have understood the settings in the particles, which is bringing us a step closer to binding weather data to the properties of snow particles. Perhaps one last thing that I should check is trail. Emitter will emit amount. This amount is divisor value. Oh, the amount of the particles defined in the trail divisor particles. The remaining particles will be used as trails. So right now we have, I think, 1000 particles. So if it's divided by 1, yeah, it's emitting that many. So there is no leftover. So there is no trail. If you do 2, the remaining 500 will be used as trail. Don't see that, mainly because the trail is not leaving any signature behind. So we'll expand this and we'll say it's always 1. So that's out. Let's see if there's any color change then. Let's go from red to blue. This might be happening because that model special material doesn't have that albedo flag turned. Here. Material, this. Okay, there you go. I believe this blue is truly this blue. We change it to green, we'll see it green. So one might ask, where's the red? So most of it should be trail. Let's change this to flat zero is like, okay, no trail left. So one is going to be, okay, all. This is doing something. Yeah, I can even see the yellow ones. Then the question is, what if we have red here? Then let's change this yellow to blue now that we are seeing stuff. So it's mostly red. Okay. When this curve changes, still red, you get to normal conditions. This way. Okay, I kind of get this. It starts very small, then it goes like it grows very quickly, and then it comes back to normal size. Here, kind of weird, but let's say the case. Then everything is starts small and gets to normal size. Here, everything is the same size. Okay, you gotta wait for the 2 seconds. I think this is the case. Okay, and when everything is flat zero, then it's all zero size. So in a sense, this is working like scale. Size modifier. And here one doesn't matter because everything is the same. because it always says the amount divided by 1, so it always does this anyway. And then if there's any leftover like this, say for 1500 will be emitted and the remaining will be used as trails. Trail particle size will vary along. So the trail is not doesn't have any size. So I'll add some size. Should have seen something. Interestingly enough. But this is also affected by the color too. Or this affects the color. Problem is, where is the rest? Where is the remaining or the original 500? I was expecting to see. Okay, they are red, kinda. Then where's the trail colors? Let's say because they are. So then I should see 500 red and 500 with this gradient color. This trail also proved to be useless, so let's. Now at least I know I have 1000 particles here. This color shouldn't matter. Let's go change our stuff. We'll look into this maybe later. Everything should be white, like snow. Let's do a quick recap and conclude the stream. So today, I implemented the snow types code-wise, meaning we now have snow types assigned or kind of calculated or let's say decided for us based on humidity and temperature. The remaining task will be to assign proper models for each one of these types. So we simulated it for 2 cases where we built basic shapes. We did the test case between Stellar and Dendrite 2 because for the date that we have for January 2nd around 7 in the afternoon, we do have the favorable temperature change to go between these two states. And also at 11 o'clock it goes from this state back to this state. So we are simulating that. Part of that simulation involves different shapes like this, which you can actually see here. Right now it's using one of those hexagonal flat looking shapes. And we have the other shape which is not here because this is not running the game code. This is just a particle system. So that was number one big thing done today. We are kind of 80% done here, I would say. Wow. If this actually was broken down to 2 steps, we will be finished with the first sub step. I will call this 80% done. The reason being that we do have the weather data, just as we are simulating the change of particles. By the way, you can actually see that change when it hits 19 o'clock. You'll see, yeah, you just saw the conical shapes to change into, like you see changing back and forth depending on the humidity and temperature. You will see snowflakes changing shape. So that's done. So as I was saying, so this one, just like we do have access to this and we have like power over the snowflake types, we could also simulate the effect of wind direction and the speed to change the direction of these particles. And to be able to do that, we investigated a lot of these properties and we've come to this conclusion. Initial velocity is important. We are keeping gravity 0 on all. Angular velocity proved to be useless. Linear and radial are also. Nope, correction. Radial proved to be useless. Tangential created some kind of vortex effect, which look cool, but which may not be necessary because to create this gust effect, we will depend on linear acceleration. So really, just the initial velocity, and sometimes to simulate the wind picking up and throwing things around, we will add linear acceleration. So those two things are needed. Scale will be needed to switch between different sizes here. We could easily start with this case and scale it up by 2 to go to this stage, which saves us from the trouble yeah. So for these two, I don't need to design 2 different models. I could be using one model and scaling it up dynamically. So this could be using the same one. We can just handle it here. And really, the starting direction and the initial velocity and linear acceleration, this is going to be enough, I'm hoping, to take care of the wind direction and speed and all the other effects. So this is for snow. And let's talk about the remaining base and items here. So this is for controlling the particles coming down, sort of blown away. There is a slightly different blown away effect needed if I show you the video. So this is the initial velocity, and we could do the dusting and such. So again, coming down, we can handle this coming down part and the wind direction with 1 particles. There is this rooftop, see it like just some residual stuff here is blown away. That has to be done with the surface shaders. So when we have shaders here, we will occasionally do sort of like particles flying away. But it's going to look like particles, but it's not going to be technically particles in Godot. We will have to do that with shaders. We have to investigate shaders to simulate this accumulation. We do have particles. Stuff is coming down, but only coming down. We don't have accumulation. So we have to combine the intensity and investigate basically time functions in shaders to simulate the accumulation effect on surfaces. And then if the wind is picking up, we have snow blown away. We could also trigger the shader surface showing some static snow stuff sort of blown away. Those 2 things may look like part of the same structure, but they are not. They just have to communicate with each other. So that's going to be done in the next days. So these later parts are going to be done as soon as we are done with the particles. So that being said, that's it for today. Next stream might be Wednesday. I think Wednesday is a safe date. We'll see how this goes, but it's moving just fine. So meantime, let it snow and stay warm and dry. Bye.